We're gonna get started. So this afternoon marks the start of the applications, AI applications, and we are lucky to have Chris here. Chris has spent 8 years across Google DeepMind and Google. He has always been working in the field of AI for environment, AI for sustainability. Has been working for organizations from small startups to big corporate like the UN. He has led the development of products, if you're familiar with Google Earth Engine, Cloud Score Plus or DynamicWorld, and he's also leading the DeepMind foundational work with geospatial understanding. So Chris holds a master in computer engineering from Villanova University, and he's going to be talking about sustainability at Google DeepMind. And of course, you're welcome to ask questions at the end. Thank you.
Thank you so much, Sophia. All right, so today, Sophia said, we're going to be talking about sustainability at Google DeepMind. And first, I just want to thank the organizers and the opportunity to speak to you guys today. This is just really awesome. Really grateful for the opportunity. All right, so sustainability at Google DeepMind. So I will start with, this is the moment. And hold on to that for just a second. And so what is this moment? What moment am I referring to? So we're hitting planetary tipping points. In 2021, for the first time in history, the Amazon rainforest emitted more carbon than it removed. So think about that. We're coughing up more CO2 than we are actually breathing in. A lot of that is due to unsustainable land management practices where trees are being burned to make room for livestock. And so you're paying the cost twice. You're burning all that biomass, releasing CO2 into the air, and now you've got livestock whose waste products are also creating greenhouse gases. So this is the theme, and just a small piece of a much larger picture that's leading to something we are all familiar with, which is global warming. So this is pretty uncontroversial at this point, that this is something humanity has more or less created as we understand it in the 21st century. But to really put that in perspective, and I know we're going to wrap up the gloom and doom soon, but we really do need to motivate this. In 2023, there was the hottest day on record in 100,000 years. So it's a 1 in 100,000 year occurrence. But then it happened again in 2024, the following summer. And so if we look at this trend, it's not just the climate that's changing. It's not just global warming. We don't just think of it, the Earth's getting hotter. This is affecting the ecosystem services we depend on. In fact, the World Economic Forum considers biodiversity loss and ecosystem collapse the second biggest risk to the global economy, and that's after extreme weather events, which we already are all familiar, are increasing in frequency. 25% of species are at risk of extinction, and a lot of this is due to humanity's unsustainable management of the planet. Not controversial. This is something we already know. So let's go back a bit. This is the moment. So what is this the moment? Is this the moment for catastrophe? No. This is the moment to act. This is the moment to act. And that's especially relevant to everybody here in the room today, my generation, your generation, for whom this is going to impact more than any other generation before. So this is the moment to act. In fact, I would go as far as to say that in our time, the most we could do for humanity is to solve a fundamental problem in sustainability. The biggest hero any of you could be would be to make progress on one of these challenges that more or less humanity is facing this existential crisis. Sorry, I'm having a hard time just even verbalizing that. This is something I think about a lot in my day-to-day work, that the most I could possibly do, the biggest hero I could possibly be, is if I was able to make progress on one of these challenges. So, luckily, something that affects everyone is unifying. So that's good news, right? So while we can attribute a lot of what we understand as climate change and global warming to the private sector, now the private sector is getting involved to make a difference. Governments and public sector are getting involved, indigenous people and local communities are getting involved, nonprofits and civil society, and lastly, science and academia, which in many cases is you. And that begs the question, what can we do? What do we do? And what I also believe is good news is what we do in this case is what we all here as scientists, researchers, students, academics do best, and that is novel research. Find breakthroughs and push the boundaries of what is possible for sustainability in AI. All right. Hopefully you feel like this is important. This is really important. I think it's really important. And luckily, I am very grateful that the company I work for also thinks this is really important. So today what we're going to do is we're going to go on sort of a grand tour of some of the projects, some of those you might already be familiar with, that are ongoing at Google and Google DeepMind that concern sustainability or indirectly impact sustainability. Then at the very end, we will talk about something you might not know about, which is a project we are working on. I'll give you a little bit more detail on that because you won't find any blog posts or anything, so it'll be more of a sneak peek on what's to come. All right, so let's talk about what we're doing for sustainability at Google DeepMind. And we'll start with the big one, nuclear fusion. So again, grand tour, let's look at what sort of projects to hopefully motivate you and help you understand and get excited about the sorts of ways you can contribute and the things we are doing. So I promise there'll be more technical stuff at the end, don't worry, but we do have to talk about some of these things. So magnetic control of tokamak plasmas through deep reinforcement learning, this is an incredibly cool project. So more or less, a bunch of researchers at DeepMind have a simulator, it's a tokamak reactor simulator, and what they're trying to do is come up with an RL policy that allows them to find stable plasma configurations. In this case, you can see a few of them evolving in the lower left. This is a joint effort with the Swiss Plasma Center. And what is really exciting for an RL project in particular, as I'm sure many of you are familiar with robotics efforts, is that we can take something that we learned in simulation and actually run it in a real fusion reactor, and it worked. There's a really cool Nature paper on this that goes by the same title, and this is ongoing research at Google DeepMind. Obviously, you don't need for me to tell you why this is the big one and why making progress towards basically free, clean energy would be so consequential for sustainably managing our planet given the amount of fossil fuels that are burned in an effort to provide the energy the world is using, especially as we are adding, resourcing AI more and more. But this is a big one, and this is really cool progress because the stability of plasma in a tokamak reactor is one of the big challenges facing net gain fusion. So anyway, this is a really, really cool one. So again, bouncing around, this is actually a Google research project, which I think is really cool. Have your mind blown, because mine was. Contrails account for roughly 35% of aviation's global warming impact, not burning the fuel, the contrails. So it's worth talking about a little bit how this works. So when a contrail is created by an airplane, let's say during the night, what will happen is there's no solar radiation, so all of the heat that's basically in the atmosphere is trapped in there. You do reflect some of that solar radiation during the day, so it's a bit of a balance. When the contrails are created, it's much worse when they're at night. But this effect of trapping greenhouse gases in the atmosphere or reflecting solar radiation leads to this impact where we're warming the atmosphere due to contrails significantly. What's really cool is, if you can see in the upper left here, is we can actually estimate which conditions are prime for the formation of contrails. We can then encourage airlines to fly around them. In some cases, it's cheaper to fly around them. You just dip below a little bit where the pressure or the humidity, absolute humidity is low. And they actually did this, which is really cool. And it led, in the study they did with American Airlines, to a 54% contrail reduction. And if you're wondering what AI went into this effort, this was using GOES data, maybe some of you are familiar, so geostationary satellite data with some annotations of contrails and actually identifying those, you can see in the upper left. So it was more or less a classifier for these contrails that then we were able to map back onto the conditions that created them. So really a vision problem that was able to translate into real world impact, which is just super cool. GraphCast, I think you guys heard from Andrew yesterday about GraphCast, so you probably don't need to hear anything else from me. But if for some reason you missed it, this is an AI model for faster and more accurate global weather forecasting. The idea is simple, but it works really well. Basically, if we can take 2 snapshots from HRES, which is this climate aggregation from ERA 5, this is ERA 5 product to assimilate all this climate data, HRES stands for high res, and then what we can do is we can take 2 of those frames and try and predict the third. Now keep doing that. Right? And it becomes autoregressive, and we can start to create a forecast. And GraphCast's trick is to use this interesting mesh grid framework rather than something like an equirectangular projected image, which you'll see in many other weather models. But it's very cool. GenCast is the latest hotness. And again, I'm not the right person to hear about this from, but just a little refresher if you haven't heard of that yet. This is a very cool and very ongoing effort. This one's an old one, but just to give you a little flavor around some of the early ongoings of DeepMind's applications of their technology to sustainability, was working on data center cooling. A lot of you probably already know this, but this is a really cool project in 2 parts. The first, on the right, was to build a good world model for a data center, right? So can we take the variables or the control variables for a data center and make a good estimate for, I think it's the power efficiency utilization, or power energy utilization, or something like that. So once we can build that simulator that's shown on the right, then what we can do is we can start to, much like the fusion RL problem, come up with a set of continuous control policy to then optimize that to lower the data center power usage when cooling. So again, this is something that conceivably you could build in a Colab notebook, assuming you had access to a large data set of data center cooling parameters. But this is something that was totally tenable. And imagine the savings in energy if Google, their data centers, they're using 40% less energy. That's crazy. So seriously, not a lot of, or a small amount of research can lead to a huge impact. So some other interesting things. We also do work that's super technical, that's behind the scenes, that is important, but isn't something that's very in your face, something that affects all of the other sort of sustainability outcomes that are downstream. This is just a simple example. Finding clouds in remote sensing imagery is really important, not only for projects like contrails, but also if you just need to see what's happening. What are people growing? What are people doing? As remember, we discussed in the beginning, land management is hugely critical in affecting how the climate changes and how we manage our ecosystems. And so this project, interestingly enough, CloudScore Plus, is basically uses weekly supervised video modeling to try and guess in a new frame what should be there and what shouldn't. Typically, this is challenging for single image models because shadows look wet. From the perspective of space, they have a low shortwave infrared reflectance, which is typically a sign that something is also wet. You can use this for inundation modeling. And so there's a bunch of problems trying to do this with single snapshots. It turns out when you turn it into a video analysis problem, it becomes a lot easier. And then we can use something like this for all sorts of downstream applications. All right, this one is super near and dear to my heart, and I swear to God, we'll stop doing this, rotating carousel of cool projects. It's just, I really do think it's important to understand how this type of research can really lead to outcomes in sustainability. So Project Sunroof, it's only available in the US and Puerto Rico, but what it allows you to do is estimate the solar potential of a roof, which there is a lot of. There's a lot of homes in the US. And as solar and renewables becomes a viable option compared to something like burning fossil fuels, this gives you a really easy way to enter your address and immediately understand what is the solar potential, give you a link to who can install the solar in your area, blah, blah, blah. It's a product, but what sits behind this is this super resolution algorithm for taking satellite data and resolving it in such a way that we can find roof segments to fit the solar panels. So it's kind of interesting. You don't really just want to know what the building outline is. You want to know the structure of the roof so that you can go do one of these binning algorithms to go actually place solar panels on it. And that's more or less what they do in practice. So this is referred to as super sunroof internally, and we're taking off-nadir RGB data and super resolving it to a DSM at something like 30 centimeters. I think it goes from maybe 1 meter to 30 centimeters. And this is a super resolution problem, which is something I think there's been a lot of research into recently, and I mean for the longest time. But using super resolution to super resolve these DSMs to better fit those solar panels on a roof has led to Project Sunroof being successful across the continental US, for which there are a lot of homes and a lot of solar potential. So again, we're taking this problem that seems simple to frame, but when you productionize it in a use case that has somebody like Google to turn into a product, it becomes really impactful. Okay, so now we've reached the part where we talk about what's next, what we're working on now, hopefully some exciting stuff. And the good news is you're getting a teaser. The bad news is I can only give you some details because this isn't out yet. So let's kind of think about some common themes across some of these sustainability applications that I presented. I also realize I'm going super fast, so we're going to have like 40 minutes for questions. It's perfect. Let me back up. A lot of these problems deal with measurements of the Earth and trying to do something intelligible with these measurements of the Earth. And I know, we've all heard it, thought about it, seen someone else do it before, but why don't we put all those different measurement modalities together and learn from them? I mean, it's the LLM recipe, right? Can't we do something like that? But can we make it valuable? Is it super valuable to just slop a bunch of images into a large MAE and do something at the other end? Sorry, slop if you're training MAEs, no shade. But is that valuable? What can we do with that? Well, it stands to reason we could learn across modalities, as is typical of the cross multitask learning we see when you train a next token predictor, because there's so many different tasks embedded in those tokens. In this case, we're going to get all of these different tasks from raster data, point data, unstructured data, and try and learn something from it. Again, leverage the same kind of power we leverage with LLMs in something like these measurements of the Earth, which it maybe doesn't necessarily make sense to throw something LLM-shaped at. So what if we could do that? What could we do? What would be possible? So one of the things we're working on now, so this, I think we had talked about this a couple months back too, so this isn't super, super brand new, but something called embedding field model. It's actually the project I work on. So this is an AI-powered assimilation of multi-source, multi-temporal geospatial data. I'm hesitant to say this, but technically a geospatial foundation model. But foundation model, that's old news. We're not allowed to call anything that. It's a frontier model. But the idea is to produce a compact, semantically rich embedding vector for every 10 meter square on the planet, and a model obviously capable of doing that. The idea is this. We keep running into these problems where we want to extrapolate measures of the Earth globally, right? It's the case for Super Sunroof. It was the case for Cloud Score Plus. It's even the case for the very first thing we talked about, right? Understanding how people manage their land. This is clearly something that we should try and solve once and not keep solving. So that's the idea. Can we make mapping really, really fast using something not too dissimilar, like content embeddings, but for the planet? That's the idea. And this thing is called embedding field model, and we're working on this today. Sorry, this is the best I can give you. So more or less, it's similar to, as I discussed, we want to take a lot of data from a lot of different sources, not just raster data, and we want to learn some fundamental truth about that data, and in the process, learn a very capable model that we can then multitask to all sorts of things. Ideally, repeat all of the labor, or avoid repetition of all the labor implicit to all these other things we talked about today. So in this case, it's oversimplified, but if we take non-uniformly sampled, sparse observations from these many different instruments, we want to encode them into something that really doesn't care if one of them is missing, really doesn't care if one of them falls out of the sky and a new one shows up, really doesn't care if you use temperature data versus optical data versus radar. We want something where we can understand the planet sort of regardless of the sources that we have available to us at any given time. That's the idea. And then we want to use this again to empower sustainability applications. So, is this any good? Is this idea any good? Sort of what's our progress? So we've been doing research in this area for about 2 years now, trying to build this fundamental capability, but we're not the only ones. There's some other groups who have also been looking into ideas that are very similar. And so far, we're feeling pretty confident with the approach that we've taken. There's not a lot of players in this field right now, but there's a few you may have heard of, IBM's Prithvi, there's a startup called Clay, and then there's some tangential models that are trying to get this at a different angle. SatClip, which is this implicit model, and data products like Mosaics. So we've been comparing our approach, and we do find consistently across the board, by combining so many sources, so many observations, you see what is typical of scaling in machine learning, where as we've scaled up the number of modalities, this theoretical number of tasks, amount of data, that we wind up with an approach that is better across every problem that we test, not just a select few for which it's particularly performant. So what is happening, not should, will happen, hopefully super soon, is we'll be releasing a data product generated with this model, embedding fields from 2017 to 2024. We're hoping to lock down a guarantee to keep producing that till 2030, which should allow solving a lot of these problems where you have low data or you're trying to extrapolate a measurement at a global scale in a way that you can actually go do something with it. Methods are great, but the policy and the impact is what's really important. Okay. So that was just a teaser for what's coming next. Thank you so much, and I'll take questions. You can have mine if yours doesn't work. Sophia's got one.
Yeah. Thank you for your presentation, Chris. It was very interesting. So I have a question about the contrails problem. And how did you manage to annotate ghost data, satellite images? Are they annotated, or there was any automatic process behind to annotate this data in order to recognize contrails within satellite images? And I think the same question is also for Cloud Score Plus. Thank you.
Yeah. So contrails, I'll say as much as I think I can because I don't know that there's a paper on that just yet. Cloud Score Plus, I can say a lot more. So for the contrail work, it's done in two parts. So there is supervision, which is designed to take a GOES image and understand what lines that more or less just show up in the GOES data count as contrails. One thing that'll immediately come to mind is, wait a minute, you won't see contrails that are below the highest cloud layer. That's generally considered okay, and that's gonna happen frequently enough because, again, we're not trying to find the contrails, we're trying to find characteristics of an atmosphere conducive to generating them, if that makes sense. So the idea is to first find a bunch of contrails and then do the reverse problem. What were the characteristics when we found them, more or less? And then we can take that and then say to somebody like American Airlines, hey, don't fly because we can use something like GraphCast to go predict what the weather might be and say, don't do that, if that hopefully answers that question. Regarding Cloud Score Plus is really interesting. So Cloud Score Plus does also use supervision, but it's a little bit different. So one of the interesting things about clouds, so contrails are also challenging, and clouds have the same problem where there's a fuzzy boundary, right? You can't really think about them as semantic segmentation because there's no clear stop, like when is the cloud done, basically. For Cloud Score Plus, so I gotta rewind the clock to remember how this works. So the idea is that there is a small set of supervised annotations, and that supervised set of annotations is designed to give that continuous scale, where a human would say totally clear, a human would say this is somewhat obstructed to completely obstructed. Then that is multiplied through an automatic process. So the contrails project, I don't think it's automatic. For Cloud Score Plus it is, where that small model that's actually, it diffs two images, is then scaled to a much, much larger corpus of images. And so you get all these examples out where, hey, I had these two things, I diffed them. And then you get that diff. But what's really interesting is if you hold out a clear image when you did that diff, you now have this cloud mask, if you think about it, right? Which is pretty cool. So you can do that, and then now that you've solved the two-image problem, now we can solve the one-image problem. And so that scales it against a whole bunch of other images, trains this video model, and there you go. Hopefully that explained what you're looking for. All right, cool.
Thank you so much for this great talk. So my question is, how do you balance the trade-off between training models on such amount of data and the goal itself of sustainability? So you would need to lower your carbon impact with GPUs, etc.
Yeah, that's a really great question. We're training giant models. Are we creating more greenhouse gas effect than we are saving? So that's a multifaceted problem. So let's talk about, I think, some of the things to keep in mind when we're trying to actually come up with solutions that use AI but aren't problematic. So the first one is you should be running on, as is possible, green data or data centers that are green. And that means a couple different things. You could be buying carbon offsets, which is okay, or you could be powered by renewables entirely. So Google uses a split of both of these techniques, paid for carbon. Sometimes they pay for carbon offsets. Sometimes they actually use data centers that are entirely powered by renewables, which is fantastic. So one of the things you can do is run your jobs in the completely renewable data centers. Now, to be honest, that is not something we did for EFM, but that's a start. So the hardware you should be running on should be either running on renewables or doing something to offset the cost of all the energy you're using. The second thing is to understand the trade-off between inference time versus training the model itself. So you're sort of amortizing the training costs basically because you're going to run inference so many times. This problem specifically, we don't want to be running a video model for every person who has any problem they want to test try some hyperparameters on. That's just awful. So that's the point of this data product. So specifically, I can't say the same for every project just because I'm not familiar, but for embedding field model, part of the goal was to make inference super cheap, like cheap, cheap, cheap. It's a combination of two factors. One, it's using Earth Engine, which uses lazy evaluation, so that when you're actually at the highest zoom level, you're looking at global scale, you're not actually running inference for every pixel that's at 10 meters or something like that. And then the other trick is to basically build such a data product such that something like a linear probe is actually effective, or even k-nearest neighbors. That's the idea of the content embeddings. So at least for the case of embedding field model, an explicit effort was made to make mapping cheap. That's a goal. I think it becomes much more complex when you have something that does require running the full forward pass at inference time, and that's when someone above my pay grade has to figure out what that trade-off is, and is this really worth it? But yes, in some cases you do have control over that. We did in the case of EFM. In some cases, you have to make the call whether it's actually worth it.
Yeah, question. So in your opinion, what is the best way for energy and sustainability engineers to contribute to the application of AI? Like, should they have the skills to apply it, or it should be the responsibility of computer engineers only? So what's your opinion on this?
So energy engineers versus computer scientists in AI, whose job is it to
apply these models in sustainability? Yeah.
Well, my answer is it's all of our responsibility to do this. I think, and I think it's not like, is it A or B? I think it's A and B. So I can tell you from both the data center cooling optimization and another project, which I really want to name internally, but I don't know. It's also related to data center power optimization. These are teams that work with domain experts. And I think it's actually a bad idea to take the initiative of someone who has, as someone who would have no domain expertise, to dive in and say, I'm going to solve this for this industry. I think connecting with domain experts is absolutely critical. So to me, it's a combined thing. It's kind of like the plasma control research project, where the actual folks who built the reactor are working with the computer scientists and the AI researchers to build something that actually works in practice. That led to some funny friction because physicists know more about physics, computer scientists know more about software, and so I think there was some sandboxing of MATLAB and other things in a high-performance computing environment to get that to actually train. But I believe it is very critical that we, connect the experts to folks who write code.
Thank you.
So, my question is about the policymaking process while you are developing these products as well. So, how Google works with the governments and countries while making the sustainability efforts in order to push the climate change agenda as well. So, what's the policymaking process and how's Google's involvement in those processes?
So I guess the first thing I want to say is I don't like thinking, I wouldn't consider sustainability an agenda. It's a problem I think we all have. I totally take it.
I mean, while I'm phrasing the question, that was the first word that came to mind.
Okay, no, that's totally fair. I'm just giving my perspective on that. So how does Google engage with governments to actually try and make a difference when it is something that's government scale or country scale? Is that the gist of your question?
Yeah.
Cool. So there are some things I am not privy to, but there are some that I am. So Google maintains relationships with research groups kind of across the board, not just at universities, but also government research groups. So for an example, the US Forest Service has a whole research arm that develops products that helps them understand what is the defoliation damage to our trees due to new invasive species we didn't know, these sorts of things. And Google's job is not to, and will never be, to influence or push a certain policy. It's to empower researchers with the tools to go solve these problems. So it's less so that Google has an agenda, we're going to go, we want this thing to happen and we're going to go influence it. It's more like, hey, can we build the tools that are making the people already doing these things get their work done much faster, if that makes sense.
All right, thank you.
Hello. First of all, thank you for the amazing presentation. Through the presentation, you mentioned a few amazing products that uses some sort of AI, some sort of machine learning to empower users. Was it individuals or organizations to make better decisions? I'm curious, as for you, as someone who's been in the field and the intersection of sustainability and AI, how do you see these field embedding models being utilized in the future? What kind of products would it empower? And if there's any kind of breakthrough you're hoping, rather than you're saying, that these embedding models would provide for either individuals or organizations?
Yeah. So, all right, just repeating the question, what is the future that we hope to empower with something like embedding field model? And the tagline that I've used to succinctly describe what it's supposed to be about is make better maps faster. So some of the slides that I used today came from a talk we gave at AGU, last December. And the theme of the session that we presented in was how to extrapolate sparse data. It was all about sparse data. So is it meta-learning? Is it zero-shot models for which there is no classification, no machine learning at all built on top? It's just inference time, or something like what we did. So what we really want to drive with embedding field model is use cases for which there isn't a ton of data. That's kind of the point. I think any of you, actually just spoke to somebody about this, have ever worked with in situ data for crop monitoring, yield, forest typology, any of these things. Someone had to physically walk out and measure something to do it. And that's a very laborious, expensive process. Again, a lot of the stuff I'm familiar with is US-centric, so you'll have to forgive me. But for an example, going back to the US Forest Service example, they spend like $100 million maintaining this FIA data set where they literally go out and measure trees. And so more or less what we observed is that this pattern keeps happening where there are these data sets that were very hard to collect, and then these very passionate and intelligent researchers who put them together realize that it's hard to extrapolate them beyond sort of the local area in which they were collected. So that's more or less the goal of embedding field model, is to take a very local data set and extrapolate that as globally as possible, I think, is the way we look at it. And the way we've been testing it is in these low-shot regimes. Like, let's say you only had 10 points per crop type, 10 points per urban land use class or something like that. So yeah, that's really the hope, is that a lot of the use cases that right now are blocked on data scarcity, we can unblock. And in terms of what breakthrough are we hoping for, we're hoping that a lot of maps that couldn't exist now can exist. For an example, one of the things I showed, I won't blab too much on it, this Canada annual crop survey, something that Canada does, where they drive out with cars, they go measure things in a field. There is no map from that data. There's just about 1,000 samples that they took. With embedding field model, you can actually turn that into a map of crops in Canada in like a matter of minutes. And you can do that on an annual time scale or even a sub-annual time scale, which for those of you who have worked in remote sensing, sounds like a nightmare. But you can do this very, very quickly. So that's the sort of thing we're hoping to empower. Yeah, I'm excited. I want to say more, but soon.
For remote sensing in general, so you have many sources probably. Can you tell us a little bit about what is the delta value, what is the marginal value for especially like embedding space field for each source that you add? Maybe I'm asking like what is the most important source for the embedding space field, and is it like more task specific? For a particular task, a source might be very important. Can you tell us a little bit about that?
Yes. Can I? Let me put it this way. That is an ablation that we have done, and I'll sort of tell you as much as I can. Again, we are working on a publication right now, so I don't want to spoil the prestige. But yes, the right way to put this is there is an effect of diminishing returns. So it's not sort of like as I add more modalities, model gets better. It more or less looks like there's a couple key types of data that end up being really important for a generalist model, And then there's a couple extra types of data, groups, that we've been referring to them because it ends up becoming too difficult to do a cross product of all possible sources and all possible orders on which you could train them, that add marginal benefit to very specific subgroups. So I'll give you, or certain tasks. So I'll give an example. Something like very simple tree genus identification or something like that. That pretty much benefits from the more data we add, we see not necessarily a saturation point as we add more cardinalities of data or higher cardinality of data. Something like land use land cover saturates really quickly once we add something like optical and maybe some radar. So there are very interesting effects for the type of task you're trying to solve, but it does saturate for most things. I know this is a really unsatisfying answer. There's a whole table of these somewhere. I just can't present it.
Okay, thank you.
Hi. So first of all, thank you so much for the talk. For me, sustainability is something that's very close to my heart, and I want to explore it in the future. So I have two main questions for you. So first of all, you work as a research engineer at Google. So how much sort of application of this research do you control or do you contribute to that's outside of your, let's say if I'm a computer scientist, then maybe that's something that's a little bit outside of my scope, right? So how much of that thing do you experience as being a Google DeepMind scientist? And secondly, this is regarding the embedding field models that you were talking about. So I'm from Pakistan. So over there, there's a huge issue of data availability, right? So the thing is, like, we get floods and like climate events, and we are severely affected by that. But there's no data points or like publicly easily available data points that we have on which we can even apply all these like cutting edge algorithms, right? So how is it possible for like third-party companies or maybe governments to contact Google DeepMind to get this data, or is this something that you guys are gonna make publicly available, for example, so that it's something that companies can maybe build upon and help solve real problems, basically? Thank you.
Yeah, and thank you for sharing like a very extant use case. So the good news is, yes, the plan is to make them open and free, available in Earth Engine as soon as we get this publication out the door. There's a couple other corporate type things that have to line up, but yeah, definitely make it available. In terms of government versus private corporations, that is more of a Earth Engine terms of service thing. I think for research use, it's totally free and open. I think, yeah, I'm not the expert there, but again, for research use, it's visible, open, yeah, totally. The other question was related to my, for an example, involvement in my experience as a research engineer at Google DeepMind with the use cases, right? With the things people actually want to go do with this if I understand correctly. Yeah, like the applied side of it. So I think it depends. It really changes, I think, depending on project to project that you work on. There is always almost one person who has a foot in both domains, but cannot necessarily be the expert in everything. So for an example, on the project we work on, I do kind of keep one foot in the application geospatial science domain, and then my other one in AI and computer science and that sort of thing. But I'm not the expert. We have folks that we work with who are the world experts in some of the domains that we care about, and are the world experts in things like scaling and the sort of science that underlies the actual algorithms. So it depends on where you sit. But there's a little bit of both. I mean, absolutely, these projects, AlphaFold, GraphCast, these sorts of projects won't exist without somebody who is directly collaborating on that team, who is a domain expert. So. Mm-hmm.
It was the same question. Yeah. Hello. Thank you for the presentation. My name is Sundus, and I'm currently doing my master's in sustainable finance. So this is really interesting, especially that I'm working on how can finance scale green technologies, and usually we have scarcity of data that is related to sustainable development. So you mentioned that the private sector is now involved in these initiatives and trying to scale sustainability. So my question is, what kind of opportunities that exist to integrate DeepMind's climate forecasting and materials discovery? And do you envision like an ecosystem or a platform that shares this, especially that investors have this low appetite for climate risk and transition risk? This is an issue. So yeah, especially if we can account for both environmental and financial variables. Thank you.
Yeah, so the question was, is there or will there be an integrator for all of these various things that we're working on, more or less, that would allow you to draw insights from across domains, more or less? Yeah, so there are some early efforts towards this. Environmental Insights Explorer is one thing I recommend checking out. I guess I'm not sure right now how available the data is to everybody, but that's taking data from projects like Sunroof, taking some of the data that's also AI generated from things like maps and building footprints and these sorts of things, pollution data, and integrating it into one system that allows you to make city-level aggregates and sort of comparisons. So there have been some efforts. There are other ones. It's another one of these things where it's hard to share the forward-looking things, but there's absolutely a strong desire to do that. And I would say the best tool right now, I wouldn't call it an analysis. I mean, it isn't an analysis platform, but it's not something that I think like an economist or a financial expert would be able to go and work with, maybe without a specialist. But Earth Engine, I think I'd mentioned that before. Earth Engine is hosting WeatherNext, which is GenCast data. They're also hosting Embedding Field Model. They're also hosting a whole bunch of other stuff. So you can get all this data through Earth Engine. However, I wouldn't call Earth Engine a platform where you free text, free form a query like what would the yield be in this place given that, or what would I expect the insurance, whatever, the cost of insurance given this catastrophic weather event. But all the data is available in one platform, and Google is definitely doubling down on Earth Engine and related ecosystem products to put all that in an accessible place. So yes, going all the way to, I don't know, a dashboard? I don't know yet. We'll see.
Just a follow-up question, if I can. Also, in addition to that, you said the M&E, like monitoring and evaluation, going on ground is usually still costly, and this is kind of the things that let the investors not willing to invest in sustainable projects because it's a very long term. What kind of, you mentioned the data things and the GenCast, but are there other alternatives that are less costly because this is also costly?
I'm sorry, I missed the first part of your question.
In terms of costs, capital costs to do the monitoring and evaluation, is GenCast still considered an expensive way to do so?
For Google, but the data is open source.
For the private investor.
I see. Well, just to be clear, GenCast forecasts called WeatherNext are available and being generated by Google into the future. And that data is made freely available. And same goes for Embedding Field Model. So if you're more or less asking, how does the private sector run their own models like this? It may be what you're asking because it's expensive, and is that
as an
economically viable?
Project, yes.
Yes. That depends. I think it depends. I really appreciate Google and DeepMind's role in trying to make that attractive to businesses, sectors that wouldn't typically be concerned or wouldn't typically spend money, invest in this area, because, as you mentioned, it is so expensive to do something like run a global forecasting model or something like Embedding Field Model. So I think that's really valuable. It's entirely possible that ends up being a moot point because you have data providers like DeepMind, Google, and other folks generating data such that that doesn't need to happen. In terms of running those models, I think there's a lot of opportunity around fine-tuning. The idea with something like Embedding Field Model is to do the expensive training and generation up front and then make it really cheap. I know that Vertex AI and Cloud has spent a lot of time making that process really affordable and really easy to do, so you're not bearing the brunt of fine-tuning a 2 billion parameter model or something like that. So there have been efforts to that degree. I don't know which way it's going to go, though. It could go either way, I think.
Thank you.
Thank you. I wanted to thank you for the sneak peek It was very interesting. I'm really looking forward to details. But my question is, since we're talking about data scarcity and trade-offs, do you think interpretability could help us determining like minimum variables or assets or features that could help us predict better? And if so, how can we balance, again, between model complexity and interpretability when designing AI systems for sustainability applications?
Yeah, so balancing model complexity versus interpretability, and doing so because I think your point was that interpretability could be a way to make predictors that were effective for sparse data.
To generate cheaper maps with less variables.
Yes, so embedding field model is 64 variables per vector, which is pretty small, even for some harmonic models that have, you know, third, fourth order harmonics. I'm assuming you know that stuff because we talked earlier. Okay, so I think on one hand, compression, doing the sort of thing we did with embedding field model is valuable, where you try and abate the need to do that sort of sensitivity analysis with predictors so that really the data you have is as descriptive as it could be, like a proper content embedding, yeah. But where opportunities lie for explainability, so I know there are other groups that already do this really effectively. So I know the Servier network has the strategy where they build base layer products. So they'll build like a canopy height product, they'll build a soil moisture product, and they'll do all these other things. And then their goal is to use those as the predictors. And rather than something like embedding field model, where you have this sort of opaque but descriptive 64D embedding. And I think there's a lot of value to doing both of these things. I think it depends on what you're trying to do. I would argue that as we go into the future, things like embedding field model should be as performant for sparse data than one of these more bespoke expert system type constructions. That is not to say that these still don't have a place, because we can understand why we are making the predictions we're predicting, and we can start to draw inferences from the prediction itself, not just we look at the map and say, okay, that's where the corn is. So I think it's still valuable and it will be into the future, but from the progress we've seen with things like embedding field model, at least internally, it ends up being highly effective to use one of these already compressed content embeddings to do something like map making. But again, I think there's a place for both.
Yeah, thank you.
And we have about 6 minutes left, it looks like. Boy, I hope it's an economics question I can't answer.
No, it's just more like, what do you think, your opinion about sustainability in general? I know you had a strong instance from the beginning, but there's also a lot of greenwashing, a lot of, we know like also this pollutes a lot, and not a lot of renewable energy does compensate for the impact. So what do you think, like your personal opinion?
Ooh. How do I personally feel about sustainability? And it's like, are you asking me what I think the prognosis is?
And like, because you also mentioned the agenda. So globally it's called the agenda, and I always had this thought it's not really an agenda. Why do we term it as an agenda? It makes it kind of sketchy as well.
Yeah, so, all right. I am not an expert on long-term climate forecasting. What I do know is that we are not out of time. So that's sort of the first. I wouldn't, if it was hopeless, what would be the point of me standing here trying to convince you that it wasn't hopeless? That being said, yes, there's a ton of greenwashing in the industry. And I think, this is a very personal opinion, I think sustainability is very attractive in some way as a way to communicate one's virtues, or to say that, well, I did this project because I really care about sustainability. And I think it's really important in our institution, being sustainability or any effort like that, ours, assuming you guys all really love it and are going to go switch tracks to that right now, to really think about what the outcome is. Because I think one of the questions was about, we're burning fossil fuels and using a lot of energy to do this in the first place, right? So you can start to call into question all sorts of things that we're doing. And, I think that you really have to make an effort to start with an existing problem. And I find that a lot of, I don't want to say a lot of, but there are efforts and there are other approaches that just want to come out and say, we made a thing and it's going to be great for a sustainable future. You know, we built this model and it's going to be used all over the world to solve all these problems. And that is something that I would like to see a lot less of. And I would like to see a lot more of, we worked with this one group that was trying to do something on the ground, has a real problem, and we helped them solve the problem that they had, rather than showing up saying, here's your model, go on, you know, sustainable for me. And I think that happens a lot. I think the conversation is shifting, at least I know it, internally at Google. There has been an eye towards, yeah, but what did you do? Like, what did you really accomplish? And so, look, greenwashing is going to be a thing that keeps happening because it makes everybody feel warm and fuzzy. But at least I know that in the technical community, there has been more emphasis on don't just do it to say that someone should or will go use it, go solve a real problem. And I'm optimistic that that will progress.
Yeah, thank you. I agree to an extent. But yeah, thank you for your response.
My time's up. Thank you.